Good morning, everybody. Today we're going to be talking about chapter 7. And if you remember, when we took the derivative of yx squared, what was it? It was y, derivative y equals 2x. Remember that one, right? How about when I ask you yx to the power, let's say 5, 3x to the power 5. What was the derivative of that? It's a 15, x to the power 4. You remember all these basic things. So what do you notice here? That whenever the base, this is called the base, and that's the power. Whenever the base of x and the power, whatever it is, a constant, then the derivative, as you can see, the derivative of that, we bring the constant down and the power a minus 1. That was the basic power rule. Now, we can always differentiate that, no problem. But how about when I give you a question like that? Y equals a to the power of x. In other words, y equals 2 to the power of x. What do you notice? The base is the constant, while the power is the variable. Or maybe a to the power, or maybe we can say y equals 5 to the power sine x. Still the power is the variable, or is the function. Y equals maybe 5 to the power square of x. So what's the difference between this one and the one before? Here, this is the base, and the base is constant, while the power is the variable. We don't follow the same power rule, the one we took in differentiation 2 or 3 or 5 weeks ago. Also, we could have the base simply a variable, and the power is a variable. All right? We could have sine x to the power x squared. Or we could have the base square of x and the power is cosine x. So, how can we solve these questions? We cannot do it in the traditional way. Think about it. You can't treat it. You cannot say, for example, the derivative of this, I know some people are thinking like this, square root of x times 5 to the power square of x minus 1. No, be very careful, you can't. So what's the solution? In order to understand where are we going, let me remind you with a couple of things that you already know. What's the derivative of ln x squared? You would have said, we put down x squared, the derivative of that on the top, 2x. And you could simplify. Oh, we know that. How about when I say y equals ln sine x? Then you should have said the derivative of this, we put sine x in the denominator, and the denominator derivative on the top cosine x. And if you want to simplify this, is cotangent x. But we're not going to worry about it now. Now, and by the way, when we take the derivative of y with respect to x, that's what we get. But what's actually the derivative of y? 1. So we don't write it down. We just write y derivative. Now, I am going to take you to how can we deal with the thing that I just erased. All right? Let me start with something very, very simple. Very simple. Let's take question number 1. If I have to take the derivative of this, what can I do? 3 to the power of x. Think about it. You cannot do it. Now, the secret to that, like we took in Math 1, why can't we play with logs? If I take len to both sides, this is the secret. Take len to both sides. This is where the secret is revealed. And remember, what happens to the power? So len y equals x len 3. Len 3 is a constant, it's a number. It's like 3x. So my advice, to think like that. Len is 3x. If I want to differentiate that, that's easy. Because the derivative of that with respect to x, simply len 3. And the derivative of len y, this is y, not 2y. You put y down here. And the derivative of y is 1, like we just reviewed a minute ago. And because we are different with respect to x, we have to multiply it by the derivative. So, you can simplify this further, or you can keep it that way. So the derivative of that one, by using logarithms, or by using the natural logarithm, which is the base e, simply the derivative of y is 1 over y times its derivative. Okay? And then the derivative of 5x, 5, 6x, 6. How about len 3x? Len 3. Let's take another example. Number 2. Why don't we take y equals x to the power of x? This time the base is not it's a variable. Take len to both sides. Len y equals len x to the power of x. What do we do with the x? This is the secret. Remember, you have taken this rule in the log last semester, which says what? Len a to the power of b, it's b len a. So I hope you will not forget that. Because if you forget it, well, this is not going to be good for you in this topic. Now, we have to rearrange this. Len y equals, bring the x down, times len x. Now guess what? We are having here two functions. If you notice here, we have a function with a constant. That constant, it can be called its coefficient. So this is the coefficient. Coefficient of who? Of x. But here, we cannot call this a coefficient. Now, we took this before. Remember we used to call it product rule? Derivative the first times the second, the product the second times the first. Let's do it. What's the derivative of the first? 1 times the x. Plus, what is the derivative of the second? 1 over x. Times what? Times x. And don't forget, since we are differentiating y with respect to x, then I put 1 over y times the derivative of y. You want to put it this way or this way, it doesn't matter the order. Some people, they've learned with their teachers in the class, derivative of the second times the first, plus derivative of the first times second. It doesn't matter. Why? Because here we have what? A plus. It makes a difference in the quotient when you have a negative. Now, can I simplify this further? If you wish, I'm not pushing you, 1 times ln x is a ln x, x divided by x is a plus 1. This has nothing to do with that. This is alone. If you get to this point, you are the best. Alright? Let's take another example. I'm trying to go up the ladder with you step by step. And guess what? What is the name of this topic? Can we do it in the normal way? No. Therefore, when you see a question like that, my job to tell you, use logarithmic differentiation differentiation to do the following. So let's have another example. Number 3. This is the name of the topic. Logarithmic differentiation. Y equals, ready? Sine x to the power. It doesn't matter. You can put any function to any function, whatever you've learned. So what is the first step? We take len to both sides. So len y equals len sine x. And the power can go down. Oh, we know that. Khalas, no need every time to remind you, what do we do with the power? Where do you go with the power? No need. Now, if I differentiate the left-hand side, it would be what? The derivative of y over y. Why? Because this is 1 over y. It doesn't matter that way. That's easier. Now, who remember the derivative of square of x? Aha. It's 1 over 2 square of x. Remember I told you, you need that? Now it's coming. Times the second one. Plus. What do you do next? What's the derivative of len x? We put sine. Derivative of sine, we put cosine. Times the first. I wouldn't go any further. All right, gentlemen, ladies, simple like that. Some teacher would love to, maybe they want to go like this. Y cross multiply times len sine x over 2 square of x plus, this is cotangent. So cotangent x times square of x. I wouldn't do that. You like it? Go ahead. You want to put, for example, this before that, like square of x, cotangent x. Hey, that's cool. At the end of the game, it doesn't matter. All right, gentlemen, ladies. Let's have example number 4. How about if I have y equals 2x, x plus 1. Nice. Don't forget, I'm not doing this. This is different. Like everything. No, this time the power belongs to x only. It doesn't belong to the 2. So if I want to take len to both sides, this what happens. Len y equals len of everything. All of that. This is multiply. And if you remember, when we multiply, we want to convert the len. Remember this rule? When you were in math 1? Len a times b, it's len a plus len b. Wow. So you can call this b, and you can call this a. By using this rule, now you remember it, huh? Good, guys. So if I have not differentiated yet, all right? Y equals len the first plus len the second. Look at it carefully. If you have any question, please ask me tomorrow in the lecture, or all right? Ask me in the class live. Sir, I don't know why you did it this way. This is the beautiful thing. You prepare and then you ask questions because you have a brain. You don't need anybody to feed you. Anyway, but one more step. Len 2 plus, bring this power down, x plus 1, len x, and many people doing the same famous mistake. They forget to put this. Oops, that's a product rule. So the derivative now we do the derivative. It's the derivative of the top over y. And what is the derivative of len 2? 0 plus, what's the derivative of the first? 1 times len x plus derivative of len x, 1 over x times x plus 1. You could simplify further, but you may leave this alone there. How? 1 times len x, and this divided by that. If you see this in quiz 2, if you get to here, you are a great person and you don't need to do any more than that. Trust me. Why don't I give you one more last example? All right? Number 5. Y equals x times cosine x to the power 2x minus 3. Let's make it here x squared. Scary. Okay? Two functions multiplied by each other. The first times the second. Oh, by the way, why don't I make it fun? Multiply it by the cubic root of 2x plus 1. Cubic root. So, let's see how it goes. Little scary, but why not? If I take len to both sides, len y equals len the first, it's a multiply, plus len cosine x to the power 2x minus 3 plus 2x plus 1. And guess what? I made the biggest mistake. Guess why? Why? Because I should have taken len to both sides. I forgot the biggest word. I did it at once because I think I'm smart. I don't want to do that way. It's a len x cubed times cosine x to the power 2x minus 3 times 2x plus 1 to the power 1/3. That's what's called taking len to both sides. I now need to expand the bracket because using the log rule. Len the first plus len the second plus len the last one. Y plus, because it's a multiply. I use the rule, that one, from multiplication to addition. Now, I should do one more step. What is it? You bring the cube down. You bring the power down. But don't forget this is down. And don't forget the power 1/3. Now, ladies and gentlemen, I'm ready to differentiate. I know what to do with that. This is product rule because the two things multiply. That's a coefficient. So, the derivative of this. What's the derivative of len x? X divided by 1, derivative is on the top. Plus, derivative of the first times the second. Plus, derivative of the second times the first. So far so good. Plus, I'm not finished yet. 1/3. The 2x plus 1, and the derivative of that is 2 on the top. And I love to simplify, but you're not required to do it. But the last step is this is 3/x plus, look carefully, 2 len cosine x plus times minus tangent x times 2x minus 3. All right? And plus 2/3 of 2x plus 1. I think this is wonderful. So this is the first part video. This is called using logarithmic differentiating to do the first derivative. The only thing is different is here. This is something that you have to know. I know it's a big subject to go from here because this is called implicit function. There are 2 or 3 chapters about that topic, but we don't need that. The only thing you need to know, the derivative of len y, as usual, len x, 1/x, len y, 1/y, len w, 1/w, right? And the derivative of x, y, w is 1. So this is written as 1/y. But because we differentiate with respect to x, we have to multiply it by the derivative. That's why we say y derivative over y. All right, gentlemen, that's it.